Hi, welcome to this video on a vertical motion model or vertical motion math problems. And we'll be using a formula, and the formula looks like this. So I'll tell you what all the different parts of the formula are, and then we'll do an example together so you can see how you can use the formula to solve word problems. So a baseball is hit into the air at an initial height of 4 feet and an initial velocity of 30 feet per second. For how many seconds is it in the air? So to solve that, we're going to use the formula, the vertical motion model, and let me tell you what all the parts are. So first we have h, and h is height. So that's the height at any point in time. So as the ball travels, it gets hit, and then it goes in the air, and then it's going to come back down. So at any point, the ball's at a height, and you can find that height at any given time, and that would be h. T stands for time, so that's the time that passes. So that's what you'll be solving for when you solve this problem, because you're looking for how many seconds. There's also -16 is a constant, and it will always be in the problem. There's also going to be two more constants that you need. One of them is v for velocity, and that velocity would often be given. It's a speed in your problem. And the other constant is s here, and s represents the initial height. So you'll be given the initial height. So in the problem here, in the word problem, we have an initial height of 4, so that's the s, and 30 feet per second, so that's the v, that's the velocity. So I'm just going to substitute those two numbers into the formula, and I put 30 in for v because that's 30 feet per second, and 4 in for s because that is the initial. So what we have here is the graph that represents this equation. I used x, or on the x-axis we have the t in time, and on the y-axis is the h for height. And you can see that over time, so this is time is passing, over time the ball is traveling up and then it's coming back down, and so it makes this arc. And we could solve and find how long the ball is in the air by using the graph. We could find where it hits the ground. It would hit the ground right here when it hits 0. And that would be fine, but we're also going to learn how we can actually solve it, not by graphing, but instead by solving the equation. So we solve first by setting the equation, or the height, equal to 0, because that's when it hits the ground. And then from there, we're going to factor this trinomial. So step 1, factor out a -1, because you do not want your leading coefficient here to be negative. So now this will be a lot easier to factor. So now I'm going to look and think to myself, okay, what can I multiply? What two numbers can I multiply to get 16t squared? And what two things can I multiply to get -4? Knowing that in the end, when I combine these things, I have to get -30 in the center. So I can create a table to help me with that. And I think, well, something times something is -4, so I'll try -2 and +2. And maybe that works, maybe it doesn't. Maybe I need -4 and +1, but I'll try these first. And then I need to split up the 16t squared. So something times something is 16. Maybe 8t and 2t. So I try that, and when I try that, I get -4t and 16t for my middle terms. Well, that's not going to work because they add up and I get +12. So then maybe I try again, and I don't change both things. I'm just going to I'm going to stick with the -2 and the +2, and I'm just going to try something else. I'm thinking, okay, well, last time when I had 8 and 2, I got an answer that was really close together. So let me try spreading it. Rather than using 8 and 2, if I use 4 and 4, my numbers would be even closer together. So I want them to be pretty far apart. I want them to be -30 apart. So I'll try something more extreme, like using 16. So I'll try here 16t and 1t and see what happens. I get 16t times -2 is -32t, and 1t times 2 is 2. Now, when I combine those together, I get -30t. So now I have my solution. And the two binomials that work are 16t plus 2 and t minus 2. In order to solve this polynomial, the -1, I could divide both sides by -1, so then I would just, that -1 would go away. And I'm going to set each part equal to 0. So that means 16 plus 2 equals 0, 16t plus 2 equals 0, and t minus 2 equals 0. I'm going to solve both of those equations. And when I do, the only one that makes sense is the one where I have to add 2 to both sides and t equals 2, because the other solution, when I subtract 2 from both sides, I get 16t equals -2, divide by 16, I get t equals -1/8. And you think, well, that doesn't make any sense. How could that be? Well, you have to keep in mind, when you looked at the graph before, remember the graph. I'm going to go back in time, go to the graph. Remember the graph back here. Here is the first place it hit 0. When the ball was hit or thrown, I can't remember if the ball was thrown or hit, it actually wasn't thrown from the ground, it was thrown from a height, it was hit from a height of 4. So if you imagine somebody hitting a baseball, they don't hit it off the ground. It comes to them and then they hit it in the air. So the ball was hit here and then traveled up and came down. So in order for this curve to work, it means in the past it would have been on the ground at time -1/8. But this right here, this section of the graph, doesn't really exist in real life. It just has to work that way in the math problem, but in real life, it actually started at this part here. So whenever you're given a motion problem where they tell you about the velocity and the initial height, that means you want to use this formula. H equals -16t squared plus the velocity times time plus the initial height. If you use that formula and the correct values, then you should be able to solve it and find the time. All right, well, thanks. Hopefully this was helpful. Have a great night.